This is LeetCode question number 994, rotten orange. This is easy question. Let's get into it. In this given grid, each cell can have one of three values. First, 0 is empty cell, 1 is fresh orange, and 2 is rotten orange. Every minute, any fresh orange and adjust for direction up, down, left, right. 2 rotten orange become rotten. Return minimum number of minutes that must last until no cell has a fresh orange. If this is impossible, that means fresh orange only the far from empty, and this is rotten. It did not impact here. So in this case, return -1. Okay, let's check it in example 1. 0 minute here, 1 minute later, neighbor is rotten, and then 1 minute later, rotten, and 1 minute later, rotten, 1 minute later, rotten. So finally, it takes 4 minutes. Second is the -1 because rotten is here to 1, 1, 1, 0, 0, 1, 1, 1, 0, 1. In this case, rotten, but it protected from rotten because there are 2 empty space. So it must be returned -1. Okay, in this case, which one we needed to use? Yes, that's right, BFS. So I'm gonna use BFS to the rotten, and then before that, I will put Q or stack. Yeah, that's right, because BFS use Q. So in this case, while I put the rotten orange to Q, I also check the number of fresh orange. So when the rotten is 1 orange is rotten, I will decrease fresh orange counter. Finally, I will check fresh counter of fresh orange. If it is 0, means all of fresh 1 is too rotten. So I will return the minute. Otherwise, I will return -1. Okay, let's implement it. First, I will add minute. I will need a minute is 0, and second is fresh orange counter is also 0, and I will scan grid for allow in range length grid, and for column in range length grid. Okay, if grid allow column is fresh 1, I will increase fresh orange counter. If grid else grid allow column is rotten, I will add location of rotten orange to Q. And I need to create a queue. I will use collections DQ. Okay. Now we have rotten orange location at Q and a fresh orange counter. Okay. Now let's BFS. While Q fall in range length Q. In this case, I will get current, allow, and current column from Q. Because we put the allow and column tuple, so when you pop up, the allow, the going to current allow, and that car going to current car. And then now I will do neighbor for direction. Okay, I will use iteration. If we use iteration, I need neighbor array. Neighbors array. Neighbor is instead of tuple location relative equal from current route. So minus 1, 0, 1, 0, 0, minus 1, and 0, 1. For neighbor is tuple, so row and column in neighbors. In this case, it get neighbor 1 by 1, and then neighbor consists of tuple, row and column. So minus 1 is here, 1 is here. Now we will change relative position to absolute position. It just add current row and column. And then we will check the boundary. If this rotten orange up is the out of boundary, we needed to skip. Or if that is not fresh one, we will skip because only fresh orange is going to rotten. It makes sense. So not 0 row to length grid and 0 to column to length grid 0 and grid row and column must be fresh, and then continue. Why I write it is this one is valid condition. That means if it's not valid condition, is the skip the after continue statement. And at this time I will going to grid row to column to rotten, and then I will decrease fresh orange counter, and I will put a neighbor location to Q. And then I will increase time. And the next minute it also doing. It makes sense. Finally, I will check if there are fresh counter is higher than 0. If there are any fresh orange, and then I will return -1. Otherwise, I will return minute. But we need to check two things. First is minute is start with 0, so it must be -1. But if there are no rotten orange, there are no Q in here, so minute is 0 -1. It is not correct, so we need to minimum is 0 like this. Yeah. Zero, 1, -1. Next. Okay. Oh, sorry. Not 0. Zero, 1 after this 0, but -1. Count need to be 1. Okay, count is timer neighbors init. Sorry. Yeah. Okay, let's check the complexity. Time complexity, it Q takes the linear space, and then it linear time, it's also linear time. So we can say it take linear time with the linear space. Thank you.